Bismillahirrahmanirrahim. Assalamu alaikum. Today we're going to discuss about adjacency matrix that will be belongs to graph theory, and the book we follow that is graph and its application, an introductory approach by Wilson. Now, what is adjacency matrix? Now, adjacency matrix that is matrix representation that we will change a graph into a matrix. Now, to define what is adjacency matrix, let G be a graph with n vertices labeled as 1 to up to so on n, and the adjacency matrix that will be present by AG of G, and we know that G is a graph, is n cross n matrix in which the entry in rows represented by I and column by J. Now, here we have an example. Here we have a graph where vertices are labeled as 1, 2, 3, and 4. And similarly, we label vertices as row 1 to 4 and columns again 1 to 4. Now, what we have to do is, if the vertex 1 is attached with itself, that will be known as loop, then we say that here we write 1, otherwise 0. So there's no loop with vertex 1, so 0 is here. Now 1 is attached with 2, so row 1, 1 that will be attached with column 2. So now next, similarly, 1 is, there's no edge between 1 and 3, so here is 0. And 1 and 4 having one edge, that will be 1. Similarly, row 2 represent the vertex 2 that will be joined with other vertices. Now 2 is joined with 1, so 2 is joined with 1. Similarly, 2 is joined with 3, so 2 joined with 3. Now we skip the 1 vertex, that will be 2 joined with 1 and 2 joined with 2 itself, that is called loop. And now the fourth one, that will be 2 joined with 4 but multi edges, the 2 edges are joined with it. And similarly, 3 and 4, you can check the vertex 3 and vertex 4. Now we have a problem that is known as write down the adjacency matrix of each of the following graph. Now I am discussing with only the graph in part A, that 1 to 5 are the vertices that will be labeled here, and 1 to 5 again all are the vertices that will be represent here. Now 1 is not joined with itself loop, so here is 0, and 1 is joined with 2, 1 is joined with 2, so here is a 1, and 1 is not joined with 3, and there's no edge between 1 and 4, so both are 0. So 1 is joined with only 5, so here is a 1. Now similarly, if we check the 2, now 2 joined with 4 by 3 edges, so we can check that 2 will join with 4 with 3 edges. And similarly, 2 joined with 1, 2 joined with 3, and there's no edge between 2 and 5. And similarly, we can check the 3 joined with 2 and 4 only. 3 joined with 2 and 4 only. There's no edge between 1 and 5. Similarly, 4 joined with 2 by 3 edges. We can check this. And 4 joined with 3 with single vertex. And 4 joined with 5 single vertex. And similarly, 5 joined with only 1 and 4 vertex. 5 joined with 1 and 4 only vertex. And the B part, I'm leaving it to you that you can solve it in similar way. Now, as we see that we can convert a graph into adjacency matrix, then similarly, if we have an adjacency matrix, then we can convert into a graph. Here we have an matrix that is in graph part A. So we can see that 1 is not joined with itself, so there's no loop here. So 1 is joined with 2 by 2 edges. So 1 is joined with 2 by 2 edges. So you can draw the graph in any pattern in any ways. I am showing that 1, 2, 3, 4 and 5 that can be placed into anywhere in this surface. So 1 is joined with 4, 1 is joined with 4. There is no edge between 1 and 3, so we can place at 0. And 1 is joined with 5, 1 is joined with 5 with single vertex. And in similar way, 2 joined with 1 by 2 edges, and 2 joined with 4 with 1 vertex, 4 with 1 vertex, and 2 joined with 5, 1 vertex. And similarly, 3 is joined with no vertex, no any vertex. So 3 is an isolated vertex that will be not joined with any other vertices. So there is no edge between any other vertex. In similar way, 4 is joined with 1 and 2 with a single edge, and with the vertex 5, 2 edges are joined with vertex 4. And similar way, 5 is joined with 1 and 2 by single edge, and by 4, 2 edges. And again, the part B, we can do it in similar way. Now, adjacency matrix for digraph. As we know that digraph is the same as a graph, but the edges are converted into arc. Edges are having directions. So let D be a digraph with n vertex. Again, same labeling with the 1 to n. The adjacency matrix again defined by AD, AD, and again D is a digraph of D in n cross n matrix in which the entry in row I and column j. The number of arc from vertex j to the vertex I to vertex j. So here we have an example that we can clear about the adjacency matrix of digraph. Now if vertex 1 is directed to vertex 2, that is 1 joined with 2, then we call it vertex 1 is joined with 2. In reverse direction, that will be count as 0. So the vertex 1 is joined with 2 and vertex 1 is joined with 4. So vertex 1 and vertex 4. Other are 0. In similar way, 2 is having self loop. So 2 is joined with itself, but 2 in adjacency matrix of a simple graph, the 2 is joined with 1. But again, here we have an reverse direction. So reverse direction will be count as 0. So 2 is not joined with 1. 2 is joined itself and 2 is joined with 4 with 2 arc. So 2 is not joined with 3 because the direction 2 to 3 is reverse. In similar way, 3 is joined with only the vertex 2, and similarly the vertex 4 is joined with only 3 because all other arc having the reverse direction. Now we have another example, the adjacency matrix of each of the following matrix. Now we choose the first again, the first diagram that we convert into a matrix. So we can easily see that the 1 is joined with only vertex 2. There is no other arc that will be from 1 to another vertex. There is only one arc that will be 1 to 2, and the vertex 2 that will be joined with 3, and the vertex 2 is also joined with vertex 4. In similar way, 3 having no ones here because all the arc are 2 or 3. There is no arc available here that will be going from 3. So the 4 having 2 edge with 2 because the 2 arc are going toward 2, and 4 is also joined with 3 because 4 are attached with 3 in direction 4 to 3, and similarly the vertex 5 are joined with 1 and 4, the 1 and 4. In similar way, if we have an adjacency matrix of diagram, that can be converted into a diagram. So 1 is joined with 2 and 5. So 1 is joined with 2 and 5. So we draw our arc from 1 to 2 and 1 to 5. In similar way, 2 are joined with 1 and 4. 2 are joined with 1 and 4. And similarly, 3 are isolated vertex that will not joining with any other vertex. And similarly, 4 is joined with only vertex 1. Here we have. And similarly, 5 is joined with 2 and 4. So 5 are joining with 2 and 4 with 2 arc. Hopefully, you can understand this complete topic. Goodbye and Allah Hafiz.